And real quick, I want to explain something real quick. I don't know if you picked up that at the end of a semester, this is a lot of you guys in your first class with me, but I get a little impatient, more impatient. Have you noticed that? I seem a little on edge. Because I get a lot of students out of the woodwork that I haven't seen in a long time, that I effectively dropped or I consider dropped. And they come to me and they say, hey man, sorry I haven't been to class in like 4 months. Can I still come in there and make up? So that kind of gets on a teacher's nerves.
They really do.
So something like it just happened right before class, that's why I'm a little bit rah. So please excuse me if my patience...
I can't believe they would have the nerve to do that.
Oh, every semester, you have no idea. So that's why if you ever notice your teacher getting a little less patient and more angry as the semester comes to a close, it's because they're dealing with exactly that. It's really funny in a way, if I could remove myself from it. Alright, anyway, so where are we at?
So I have another question as I was working through your examples. 4B.
4B?
Yeah. Can you set that up and just work through it? Because when I'm setting it up and I'm working through it, I don't think it's right. It doesn't feel right, but I don't know why.
Alright, so there's two main ways to solve this, and on that test that we had these on, I actually made you do it both ways. I made you do it by, well, what are the two ways to do this problem?
Yeah.
Well, both ways require an LCD. So that still doesn't answer my question. What are the two ways to do this?
You can multiply the 2 times 9.
So I can leave it in this form, but I'm going to have to do what? This is 2 and 2 ninths minus 1 and...
2/3. Oh, 6 ninths.
6 ninths. That's bigger than that. I'm going to have to borrow.
That's okay.
You can borrow if you want to. That's one method. Or you can just, from the beginning, change them into improper fractions. Right?
Okay.
Either way, it's fine. All right, so it depends. If you like borrowing, I love it. Kick ass. Do it that way. It's just to finish this out doing the borrowing way. 2 and 2 ninths minus 1 and 6 ninths. I know I have to borrow, just like if I had 12 minus 9, 9's bigger than 2, I got to borrow. Here, 6 ninths is bigger than 2 ninths, I got to borrow. So if I borrow 1 from a 2, 11. It becomes 9 ninths. 1 is 9 ninths. So if I borrow 1, I can put 9 ninths on top of that. So that would now become 1 and 11 ninths minus 1 and 6 ninths. That's borrowing, which a lot of us don't like. But now, real quick, I want to show you something. Let's finish this out real quick. So this will be 1 minus 1, 11 ninths minus 6 ninths, 5 ninths. So we'll do the second way here in a second, but go with me for a second. Many different ways is there to use the word second. So we got 9 times 2 is 18 plus 2 is 27. Yep. If I had 20 ninths and I said change that into a mixed number. Now I'm going to do it and I'm going to make a mistake. So I'll do 9 into 20. So far no mistake.
2, 18.
I say 1. I made a mistake, right?
No, you went over too far.
2.
I'd like it. Let me make my mistake. Now, I know it's a mistake, and you know it's a mistake, and the fact that you want to come up and hurt me is nice. It's good, because that's silly. Why would you do that, Chef? That's crap. But 1 and 11 ninths is a valid way of writing this. Valid in the sense that math would say that it works out to the same number. But it's invalid for us because we don't like bigger on top. That's the whole problem with this number. When I change it, I don't want it to have that problem anymore. So the mistake I made was I didn't go enough times. But as you have a borrowing, made 2 and 2 ninths become its alternate, ugly looking, but still numerically valid form. Do you kind of see that? So borrowing is a way of making this kind of mistake work for you. It makes this one top heavy so it can handle the fact that that was bigger than what it was. That's why borrowing works. All right, maybe. But what's the second way to do this? I started it over there. 9 to 2. So that's 20 ninths minus
4 plus
5/3. 5/3.
Yeah, 5/3. So then you can make the LCD like we would here.
Yep.
15/9 and 20/9 minus 15/9. 5/9. Of course, the same answer because they're the same numbers. They just look different.
The second one, right? The second. So that's the.
Now listen. I never say you have to do it one way or another. But believe it or not, there might be some people there that like this way better.
As long as you get the answer.
Yeah, to a point.
To a point.
Thankfully, math, believe it or not, is not always just about getting the answer. Believe it or not.
The path taken.
Dude, it's very deep. All right. Or at least we try to get people to understand that. So where else we go?
4C. I've worked through the problem, but then...
Let me real quick get Moki and then I'll come back to 4C.
Okay.
I have this for 6 in the practice. I have a hard time writing it into like the Word format and then putting it like transforming into decimal. When it's over 25, I can do it in like hundreds and thousands and 10,000. That's kind of hard when it's
So when I give you a fraction like 13/25, that doesn't go directly into a decimal. You could still technically give it to me in words. In words, this wouldn't be 13/25 like I just said. I mean, what would it really be? How would you read that off? How would you read this off? Now think about what you just said and apply the same reasoning here. 13/25. Right? So if you wrote 13/25 next to that, I cannot take any points off. That's that fraction in words. I love it. Does that help you when I'm asking you also to go to decimal? Why is this no good of a form for going to decimal?
25 whole square root 13.
Yeah, it will. But more importantly, decimals come directly. What's really nice about this number when I think about decimals versus that number? Decimals are always based on powers of 10. And 25 is not an integer power of 10. It's not 10, 100, 1,000, right? But how could I make 25 become one of those numbers? Multiply by 4. So if I multiply by 4, good. I get 52 over 100.
So you would 13/25 is correct as to write it.
Yeah, you could write 13/25. That's beautiful. That's exactly how you'd say that. Or if you change it here first, you then would say 52/100, which is also completely beautiful. Right? How do you say this number here?
1,500.
1300. All right, I was waiting for somebody else to give me that. It's either 1300 or it's 1300, right? So there's a couple different ways to say that number. So why shouldn't there be at least a couple different ways to say this number? It could be 13/25. It could be 52/100.
That would be crazy.
There's actually an infinite number of ways to say it, but let's not go crazy. Just depends on the way you write it. And now, going from here, can you go to the decimal now? What would that be as a decimal? Yeah, tenths, hundreds.
10%.
I'm not sure how that works in. What place is that?
It's more like baking.
We are all roughly 8 years old. So how do I go to percent from there?
52%.
Yeah, once, twice over, 52%. Percent number is always bigger than the decimal number. That's one quick check you can make at the end to make sure you went the right way. You know, it's always twice. It's all about which way to go, though.
How do you do percent? Just go back.
Yeah, just move to twice back. Remember to go from D to B, you go that way. From B to D, you go that way. And it's always twice because percent is based on out of 100.
What if the number doesn't fit into 100 perfectly?
I love it.
Yeah.
So what if I had given you
3 eighths.
I already done 3 eighths. Let's do 3 sixteenths. What would you do? 16 does not become 100 nicely.
Yes, it's
0.
5, 24.
Multiply by
0.18.
by
Maybe.
100.
I'm just trying to take this bad boy to a decimal. Right? Yeah. Yeah, yeah. Or actually leave it alone for a decimal and then move it over for a percent. So you multiply 100 when you want to go to percent. So this would be 16 goes into 3.
0.1875.
Do it again.
0.1875.
1875. Yeah, sounds about right. So that's as a decimal, and then to make it a percent, move it over twice. So it's a decimal, percent would be 18.75%. In words, this would be 3/16. Cool.
So my question is probably your question, but why did you add all those zeros?
Because 16 doesn't go in 3.
Yeah, I knew ahead of time it was going to take that many. When you divide by 4, you normally need to have 2 just in case. Divide by 8, you need 3 places. Divide by 16, you need 4 places. And that's one of those things you pick up when you do enough of this stuff.
Oh.
Right? As you do it, though, you'd have to add that many zeros if you had to do that out long division-wise. You would see it wouldn't go in evenly until the very end until you get to 5. Yeah.
So the one right after that one, where it has 317,000 is already written out for you, and it says for you to put it in a decimal and a percent. And I understand how to do that. It's kind of what we just did here, but now you're going back to writing that into a fraction.
Yeah, that's when it's in words. To go to a fraction, let that be easy. Is there a word "and" in there? So is there a whole part to this? No. If there was a whole part, it'd be whole part and blah, blah, blah. So this whole thing is the decimal. What place is it in? Thousands place. There is no 17 thousandths place, right? I always have people try to find it. And they actually do find it. I'm not sure how they find that place. But there's a thousands place. And what do you want in the thousands place? Tens, hundreds, thousands? Yeah. 317. So on the 7, so the 3, 1 fit in there. That would be as a decimal. But how would I write it as a fraction? It would just be 317,000. It's exactly how it sounds. 317 thousandths is exactly what they say. This is exactly what you would think when I said 317 thousandths. You might hopefully think about this fraction here. Let it be that simple. So if I said 52 10,000ths, what fraction comes to mind? 52 10,000ths. Yeah, 52 over 10,000. Don't let that be difficult. If I give it to you in words, I'm basically telling you the answer to what it looks like as a fraction. Because the words are based on what it looks like as a fraction.
And there's a percentage of 317. You just move it.
Oh yeah. So to make this into a percentage, once, twice, 31.7%.
So we have 0.003. How would you say in the words? Please have a 3 10,000, so like 3 10,000.
The way you said it, it's not quite that far. 0.003.
Yes.
Tenths, hundreds, thousands. 3 thousandths.
This is always going to be twice.
All right, cool. Maybe. So let me come back to, do you have something else?
Do you have an answer sheet of this?
Yeah.
Have you passed it out yet?
Nope.
Okay.
Maybe on purpose.
Yeah, we have to be like, yeah, that's what I would do.
Yeah, exactly. Oh.
If we had a whole number, how do you get to percentage from that?
All right, so if you had...
185, so $185.
Gotcha. Or not even dollars, because then that wouldn't make any sense to make that a percentage. But like, it increased by 185 times. And I want to say, what does that increase in percentage? So guys, if something increases by 100%, how many times bigger is it? Twice big. If it increases by 100%, it's twice what it was before. Think about it. If I have 5 things and it increases by 100%, 100% of 5 is another 5. Now I've got 10 things, so it doubled. So if it increases by 200%, it's 3 times bigger, increasing and so forth. So if I say it's 185, it's increased by 185 times as much. Well, twice is 100%. So 185 times is going to be a stupid big percentage, right? But so if I just have the number 185, and that's my decimal. And I know it doesn't have a decimal. Yes, it does. I just don't need to write it. So it's officially in decimal form. How do I change that to percentage? You do not let numbers tell you what to do. We're the humans. We created them. We tell them what the hell to do, right? So I know when I'm in decimal, how do I get to percent? I'm in the decimal place that way. So currently it's right there. Once, twice. It's that much percent.
What I'm saying is, if you had 185 and you want to figure out what's 20% of that.
Oh, okay. All right, I thought you were talking about this.
Yeah.
If you had a whole number.
Yeah.
All right. So you mean like what is, like 20% of 185 or something?
Yeah, something like that.
All right.
Like 7,
I'm just
7A and 9.
Yeah.
A and B on the example.
7 A and B. And setting it up.
But I don't know if that's really what you're asking, because if you can put it in this format, it goes directly into math, right?
It will be X equals 20% of. No?
0.20,
Okay.
Math doesn't like percentages. It's something we created to make the number look nice. Math doesn't need the number look nice.
Right.
And then of course, the percentages and fractions of something means times. Yeah.
X equal.
X equal number, like.
Right.
Yes. 37 in this case.
So going back to number 7A, the proper way to set that up, 12 is what percent of 20? Would that be written out 12 equals X over 100 times 120? No, that's what it says. 12.
It all depends on the way. It all depends on the way that you want to set this up. The way I've tried to show you, and the way that I automatically look at it is, I don't want to bring the 100 in at all. And it's much better, I think. There's certain shortcuts we teach that actually make students never have practice with what the hell's really going on. And having that 100 kind of show up completely takes away the idea that I'm moving the decimal around. It kind of does it for you, so you never really see it happening. And I just always think you're losing something. So here, if you just keep everything as numbers, 12 is what percent of 20? Now, what form is this going to be in at the end? It's going to be decimal. So to answer the question, I have to make it a percent. Okay. Well, no. Is this cool? This is directly from English to math. 12 is what percent, I don't know, of means times 20. Now just solve for x. How do I solve that for x?
Divide by 20.
Yeah, it's x times 20. I want to divide 20.
X equal.
X equals.
You are infinitely helpful. X equals a number. point number.
Six.
Yes, 0.6. It's even more helpful. I dare you write there's an answer to one problem. No. Tell me I am wrong.
0.06%.
No?
You gotta go the right way. So again, if you write
You're right.
decimal percent in alphabetical order, right now I'm in a decimal. Where do I have to move my decimal place? That way. I gotta move it that way.
60%.
So 60%.
Make a song for this.
I don't make songs. My colleagues have songs and graph. This way.
Will you do the sort of little write that whole thing out? Like if I just put 12 divided by 20?
No, there's other ways to do this. So as long as you show me the work you're doing to get to the answer, don't you just put an answer down? I'm okay. So this is one way to do this. And this is a way that I kind of recommend if you're just starting out with this or if you're not really sure how to do this. But if you already have a way that makes sense to you, as long as I see what that way is, I'm okay. So there's that is over of, so you just put the part divided by the whole, 12 over 20. I love it. Nothing wrong with that. It's just like that grade problem where you said 4 A's out of 30, so you just put 4 over 30 to figure out the percentage. Yeah.
So then on the second one, where you have, since it sounds like you're doing away with even putting the 100 there.
Where'd that 100 come into play? What's 0.6 times 100? 60. But if you want the 100 to show up, there is a way.
I was thinking like in the book, it's showing that way in the book.
You can do it like this here, right?
Yeah.
Yeah, you can do it like that.
So in the next one then, where the difference between 12 is what percent of 20, and then you have 7 is 30% of what? And then the what is always going to be your x, right?
Yeah.
X, so
if you want to do it this way,
7 equals,
so 7 is,
right, is
what 13%, so 13 of what? Of, I don't know. So then you can solve that.
then you cross that.
Yep. That's perfect. I love it. That's the method the book shows you. Works fine. Nothing really wrong with it. I just think you're going to have to do word problems, a lot of freaking word problems in the next 2 courses you take. And the more you get used to translating from English to math, the better. And the more you're really working with the numbers themselves instead of having a form that has the work in it, that's even better. But like I said, if you already know this way and you like this way, I am not here to tell you you can't do this way. This is a perfectly valid way to do it. I just hope you get enough practice to get ready for, word problem stuff. And you probably will. You'll be fine. Yeah.
So I just wanted to ask for number 6 again. When you're writing it, you have to have the at the end, after S, or else it's going to be wrong.
Yeah, because hundreds already means a lot. So if I had 6 hundredths of dollars, that's much better than 6 hundredths of dollars, right? Because the second way means 6 cents, and the first way means I got 6 crisp $100 bills, right? Or even if they're not crisp, I'm not picky. You with me?
Yeah.
So that THS is stupid important. It really tells me what place of the decimal I'm on. Below is THS, above, no. Below you got a lisp, right? And above you don't.
What would be the percent for the
30,000.
3,000?
Where am I at, sir?
30%?
Number 6.
For which one? Oh, it's already in decimal form, right?
No percent.
I know, but it's already in decimal
So
form?
we move it over 3 times?
No.
2
Twice.
0.
Yep, 0.3%.
Yeah, you cancel out.
So if I had
We had it backwards.
0.003, what is that as a percent? From decimal to percent, I go that way. Once, twice,
I see.
0.3%. So another part of the question really is, to get to a percent, what's the easiest place to come from? Well, normally a decimal, because then I just have to move the decimal around. So I'm not going to try to go from the written in English to a percent. No, that's crazy. I'm going to go to a decimal, and then I can go to a percent from there. Right? So it is sort of a, how do I get to what I don't know? Where do I want to start from to get there? Right?
Maybe you answered the question already, but why do we only go 2 times?
Because what's the percentage symbol mean? What's per cent?
100.
Per 100. Yeah, so it's got that 100 built in.
I think I have 1,000 with 3 times.
Oh, yeah. Say again? This first one here? You don't need it, but it helps to really show there's a decimal there. Because a decimal is easy to lose.
Oh, yeah. I was asking, is it like 3% or do you have to have it?
Oh, that's worse. Okay, so this has definitely got to be 0.3%. And that 0, just make sure that everybody can see it. It's a point there. And 0.3% is very different than 3%. Right, so if the economy suddenly increased by 3%, if it's 0.3%, I mean, that's 10 times less is really what 0.3 is compared to 3. Do you see what I'm saying? Because 3 divided by 10 is 0.3. It's a big difference.
So sorry, you put that in words.
From here.
So that would be, how do you say that?
What place is it in?
Thousands.
Tens, hundreds, thousands. So then you just say 3 thousandths. Because how do you say this word here? 4,000. Why do you say that? Because 4 is in the ones, tens, hundreds, thousands place. So it's the same thing with the decimals. We just don't get as much practice with the decimals. We don't even realize we're doing it here. But we do. We find the 4, we say it's in the thousands place, and I call it 4,000. We do that so stupid quick, we don't even realize what the hell we're doing. Here, we got to go, I find the 3, what place is it in? Because we're not used to it. It's in the tens, hundreds, thousands place, so what do I call it? 3,000ths. Same exact thing we do here. It's just not second nature because we're not used to dealing with that side, with the decimal as much.
Can you turn it into a fraction?
Yes. So just like we just did, I mean, in words it's 3,000ths, and the beautiful thing with in words and fraction, they are exactly the same thing. So if I say 3,000ths,
3 over 1,000.
3 over 1,000. 3,000ths. Yeah.
Question number 10, it says more areas and some volumes.
Yes. I'm just saying that's the kind of problems that are going to be on the final. Yeah. Just to make sure it's not just going to be a triangle problem. It could be a cylinder problem, but like I said before, remember, if it's a volume problem, I will give you the formula. If it's an area problem, you got to know it, and if you forgot it, just come up and ask me. Right? I'll harass you for a minute, and then normally people come up and they're like, I don't know what it is. I say, write down what you think it is. And then 90% of the time, it's exactly that. You just aren't confident about it. So you can always come up and say, is this right? Or if I don't want to tell you, I won't. But if I want to give you a little help, I can tell you. Yeah, that's right. It's a test you're supposed to know. So let me see if you guys know this. This is not a question on the test, but what's the most important skill to come out of this class with? Have I said this enough? Let's see. I love it. Solving equations, right? Everything else is important, don't get me wrong. But if you can solve equations, you are that much ahead of the game in general. Trust me. Word problems, ugly, right? And they're going to get a little bit uglier. You know it. But they're all going to boil down to an equation, and you cannot solve it if you don't know how to solve an equation. So almost everything boils down to solving some kind of an equation, right? And I still see a few people having some trouble. Most of you guys seem to be pretty decent with it. You understand the process. And just don't forget, the process doesn't change. If you go decently far in mathematics, you're going to learn all these weird-ass functions. And they're functions like plus, minus, divided by, times, but they do weirder things. But if I see it in an equation, I just do the opposite to kill it. I mean, that process never changes. It's almost silly that's awesome. Never doesn't change. Math says just keep doing the same damn thing. Just undo whatever's there, right? All right, let me give you guys the answer key, or else you're going to revolt and come up here and grab them anyway. I can feel that building.
Oh, I didn't do that.
That's more.
What time was the final exam?
6:05.
6:05. What room? This one, yes. Why would they change the room? That would be so remarkably evil. I'll be somewhere else going, see big fine. So, I was there.
What's going to be 6:05 there?
Number 10 isn't on there?
Oh yeah, no. Because what could I could have been a real dork and said, okay. And you should expect this, that there will be two parts to the final. Right, there's going to be the part 1, and then there's part 2 where you cannot use a calculator. What's that? I don't know, some part. I'll figure out which one's going to make it easier on me to keep track of stuff. Bless you. Don't worry, you don't have to know that now. I'll make it very clear on the final, which part you can use the calculator on.
Can we use the phone still?
Wait, still? What's that word still doing in that sentence?
I was trying.
Never can you use the phone. Yeah.
Good effort.
It's funny.
Good effort.
The phone has way too many lifelines. Yeah. Yeah, Kaiser.
No, I mean, did anyone ask that? Because I was late.
Oh, no. So 1K?
Yeah. I still get confused because I don't know if it's a negative or a subtraction, and I know you said.
Oh, I got you. They're the same thing. And let's look at 1K, and then I want to show you an example of something that's happening a lot on equations related to that. All right, never forget that subtraction is just adding the opposite. You with me? I can rewrite 2 minus 5 as 2 plus negative 5. So you do not have to do this. But the truth is, this is plus negative 8, and that's plus negative 6b. So I got a 2b, I got a negative 8, I got a negative 6b, and I got a 9. Right, for a minute I was like, is that an 8?
Yeah.
Thankfully I don't write my own tests. Can you imagine that? So you don't have to do that, just keep it like this. But when you start moving stuff around, I always get people that show me, that they put 2b minus 6b, and then for some reason it just comes minus 9 plus 8, like they move the 8 back here. But the 8 went. It didn't take its sign with it. But that doesn't even make sense. I've got a negative 8 here. If you're going to move it, how could it suddenly become 8? It's negative 8.
Negative 6b minus 6b.
Because of this. It really is negative 8. We just made this more concise way of writing plus negative 8. We don't want so many signs in a row. So I don't really need to move anything around. I got a 2b. That can go together with negative 6b. 2b minus 6b.
Where's number 10?
Number 10 is not a problem, so there's no answer for it. So it won't appear on the answer key.
So you don't have to do it, or sneaky fast?
No, you have to do it. It's an essay question.
Oh, cute.
You have to bring it with you. No. Yes. You got to pay attention.
Thank you.
All right. I'm serious. No. So -8 plus 9, yeah, plus 1. Cool. Now, what's happening in equations, like this example here, I'll get somebody to say -7, -7, and then I'll say y equals 4. Yay. Yeah, the negative, where the hell? It just kind of floats away. That negative is stuck to this y. It is a negative y. So if you make the 7 die, this is still a negative y, and I'm not done yet, right? What's my last step?
-1, -1.
Okay, divide by -1.
Y equal,
Let's try to be 4. Do you guys see that? So I'm not seeing that a lot, but I am seeing that every now and again. Solving equations. So you got to get used to the way things are. And it's really a question of how things are represented and what they mean. So when I write minus, we've had a lot of discussions about this semester, minus and subtraction are the same. There are two different ways of writing the same thing. So when I see 2b -8, that is a -8. Not just -8, it's the same thing as -8.
Okay, number 9. Why you not adding a plus b like a plus b?
Say again, sorry.
Number 9.
Yes?
You put 100 minus 255. Why minus is not a plus?
Oh! So, in this equation, which side is always by itself? C. And what's C always? The biggest side. Which one of these is A and B? Who cares? Normally put A there, but it doesn't matter. The other two sides squared add to B the hypotenuse squared. Doesn't really matter which one is which here. So in this problem, I know this is, what was that, 16 and 20. I chose to call this X. You could call it A, B, Y, who cares? I call it X, I don't know what the hell it is. I need it. So when I fill in this equation, what definitely goes here? 20. So 20 squared.
16.
Good. Sure, 16 squared, and that must mean that this one was X. So how do I solve this for X? I subtract
16 times 16.
16 squared. So 20 squared is 400. 16 squared,
2, 5, 6.
56. Cool. And you can go from there, yeah.
So 400 minus 256.
So it is a plus in the equation, but because I didn't know something on this side, I got to subtract to solve it. So the equation starts with a plus, but it all depends on how I got to solve it. Yeah.
I have a question. So are you gonna do one triangle like this and then you do the Pythagorean theorem and then you find the area in the perimeter, or are you gonna do like?
Yeah, I seem to like that problem, so it might be good to know how to do that. Yeah. You know I'm going to have a Pythagorean theorem problem on it, somehow. And it would be most efficient to tie it together like this into one problem with 3 parts. Yeah.
So the perimeters is you just add them?
And the perimeter always, no matter what the shape, you just add all the sides around. That's why there really are no perimeter formulas to ever memorize, even though many of you already know one.
So with the area, the half before the 16, is that just part of the formula? Or?
Where are we at, sir?
The same one. Same problem. Right?
That's just for triangle.
Oh, okay.
For the 1/2 BH?
Yes.
That's just for a triangle, yeah. Which shape is related to that? Which shape has got a area formula that's sort of like 1/2 BH?
Rectangle?
Which one's like a triangle, only had a bad day?
Trapezoid?
Trapezoid, right? Had a very bad day, had his head cut off. Right? So that's the one that's 1/2, it's not 1/2 BH. It doesn't have one B, it's got 2 B's. B1 plus B2, because it's got 2 bases. Right? Just trying to help you remember that formula, because remember, you have to know the area formulas. You don't have to know the volume formulas. Maybe. Possibly. Yeah.
For number 8, the formula there, and then you can choose whatever numbers that you want to plug in, right?
Yeah, I think on the test, I'm probably going to put some numbers down there. Because I don't want somebody to pick numbers that give them weird. Because if you pick the wrong number, if I would have put a 10 in there, I would have gotten 23 out, and and then who knows, you might try to fit it on your graph, and you might go a little crazy. So, but in general, if you pick a number, if you put like a 2 in, and 500 comes out, don't use that, right? Unless you have to, unless all your numbers are like that, and then you just got to make your scale. Not 1, 2, 3, 4, 5. Make your scale 100, 200, 300, 400, 500, and then you can fit the 500 on there. You with me?
Yeah.
Yeah. But most of the ones we're going to look at, they shouldn't have outputs like that. But in general, your outputs could be anything. But on the test, I'm probably going to give you some to do. Yeah, just to make sure somebody doesn't freak out about getting weird outputs, right?
For
Yeah.
the areas, I have formula square, rectangle, triangle, and circle. That's about it.
Say again?
I have the formula of area, rectangle, and triangle, and circle. That's it, or do we have to?
Rectangle, triangle, circle, trapezoid. Oh, yeah. Or a little trapezoid.
And can you draw the shape so I know what you're
Oh, yeah, so you start with a triangle, and you cut its out. These two sides have to be parallel. Cool. And you know, there is the parallelogram, but it's basically the same formula as the rectangle. You just got to use the right height. The rectangle is easy because its height is the side. Parallelogram, the side that's not fair. We had the whole thing where I was leaning. It's got to be the true height, the one that's straight drop down. And now you can see why, if I cut this bad boy in half, I got a triangle. That's why its area is 1/2 base times height, because it's 1/2 of some parallelogram.
Is number 10 for bonus also?
No.
Sorry?
Number 10, is it for bonus?
No.
Are we going to have those questions?
Yes. The bonus questions are not going to be tied to anything specific. They could be from any subject we talked about. And you can expect final exam bonus questions to be difficult. Yeah. But sometimes the bonus questions are hard because you don't realize how easy they are. That they're quick, but you're like, there's something you got to realize about them. So hard doesn't mean it takes a long time. Hard just means you got to really see what's going on.
So for number 10, it's just going to be...
So in case you came in after I said this, if you just haven't got enough practice, you go to the very back of the book. There's an answer key for a practice final exam. In the book also, it's different from the one I did. So if you need some more practice, there's more in there. You've got the review sections for each chapter. So if there's a chapter you had a lot of trouble with, just go to the review section. All the answers to the review section are in the back of the book. All right, so it's a good place to go for that. You have all my videos.
Is it streaming right now on its own, or do you have to go home and upload it?
No, it's just like any YouTube. No, this is not directly linked.
Oh, okay.
Like somebody's watching this, and so he's gonna call me. Look up behind you. Who is behind you, Jeff? No. This is not. paranormal Grossman activity. No. I'm walking around my phone. No, sorry. You didn't see the last paranormal activity?
I love it.
I eat that stuff up. Huh? I love movies that you got to think a lot, but sometimes you just need a movie where you can just check your brain at home, right? Get some popcorn.
What about Adventure Time?
Come on. That's somewhere in between. Yep. 9.3. Number 18. Oh yeah. So they really make that thing look kind of weird. So all these shapes, they can be oriented any direction. What's kind of nice is they actually tell you it's a parallelogram. I would have to do that if I drew my own shapes, because there'd be no way to tell from the shape. I sort of did it the wrong way, but all. Alright, so they tell you it's a parallelogram. That looks more like a rectangle, but too bad. And they say this is 6 meters. And then they give this weird little offshoot thing, and that's 4 meters. But the thing to realize is that's perpendicular. That must be the true height. That must be the height. So what's the area for a parallelogram? Base times height? Yeah. So the base is 6. It's just somebody picked it up and tilted it around. So you can just kind of do this. Right? Who would have felt it? So we got 6 for the base. Height is 4. 24 meters squared.
That's it?
Yep.
Oh, okay. I feel like there was more brain to it.
No. So yeah, the book, you just kind of turn that thing around when they give you your shape all freaky. If I do that to you, and I've been known to do that to you, give you a triangle that's kind of like jutting out there in space, just turn the page and look at it normal.
So would 21 be the same, but you're just finding...
21, I'm glad you asked about 21, because whenever you have a shape there's no formula for the letter L area, right?
Yeah.
Not really, I mean, yeah, no. Exactly, so you want to cut it, you can either cut it like this, you cut it like this, or you can cut it like that. But the problem I saw with a few people when they did this, I saw a lot of people cut it like this. So you got, this one's 5, this is 10, and this whole damn thing is 17. But if I find this area, and they tell us that this is 3. So if I do 5 times 10, and then I do 3 times 17, and add those together, have I made a mistake? Yes. I added this little piece twice. So I better not use 17. I better use 12. Because that's 5. That's 17. This must be the rest. This must be 12, right? So if I slice that there, I've cut 5 miles off of here. That must be 12 miles left. You with me? So that's the big mistake I saw. Somebody cut it up, but then they used the whole thing. So they added this area twice. So now you just got to do this rectangle, which would be 36 square miles, and this would be 50 square miles. So the total would be 86.
That's the perimeter, right?
No, that would be the area. Area and volume very often involve multiplications, whereas perimeter involves just adding. So to find the perimeter of this thing, it would be, if I start adding, this would be 17 plus 3. Now we get a little interesting here. This, of course, we already figured out. is 12 plus, no, it's this.
15?
No.
No, that's,
This whole thing is 10,
so that's
but this piece is 3, so this piece must be 7. So I got 17 plus 3 plus 12 plus 7 plus 5 plus 10. Aw. If perimeter is add up all your sides, your first step probably should be find out what the hell your sides are. I mean, that just makes sense. So, I mean, on problems like this, you got to realize this is the way you got to think. If I want to go here, which is not 17, it's only this much, that's how much you cut off. Same thing I had to think here. This is 10. So this must be less that. That must be 7. That's the kind of thinking you have to do when you have these funky little shapes. You want to cut them up, you better cut the sides too. All right.
So like 24 have the same concept as that?
24 is nowhere near as hard because they really just stuck two shapes together and there's not overlap. So you got a parallelogram and you've got a rectangle, possibly square. So, in fact, that one's really evil. You pretty much have to assume that's a square.
Right, that wish I did it.
You have to.
Well, it gives you a rectangle.
But that just means it's rectangle. The problem is I don't know what the sides are unless I assume it's a square. So look at number 24. Because the rectangle and the square both have 90-degree angles. So that's not good enough to tell me which one it is. 24 plops this dude on top of this dude. So they do give me that this is right angle. That's nice. But I need to know what the side. Now, how long is this side here? I know how long this side has to be. Yeah, it's 5. Because that side's 5. That side must be 5 inches. But there's no way to figure out that side from the picture unless I assume that that top thing is a square. You guys see that? If I don't assume it's a square, then this side could be anything. Because there's nothing that tells me how long that is. It's not, this was easy because it's across from that one. That one's across from that one, and I don't know either one of them. So if it's a square, though, if that's 5, then that's got to be 5. 5. Now what's really neat is trying to figure out, did they give you this? Oh, they don't ask you for perimeter anyway. But if they ask you for perimeter, what would be really difficult is figuring out that side length. But they don't ask you for perimeter, so don't tear your hair out on that. They just want to know area. All right, so now you just got to get the area of this parallelogram. What's the area of this dude?
Oh, like
5 times 4. Yeah, base times height. So I'm not worried about this guy at all right now. I'm just looking at the parallelogram dude. So him by himself is 20. Right, 4 times 5, base times height. And then the area of the square. Careful, I'm not talking perimeter now.
25.
Yeah, it's 5 times 5. So the area here is 25 square inches. I like it. And then so the total area is 45. Now in Math 90, you'll see problems like, and they'll have, or something weird, they'll have like a shape cut out. Can you do it, Jeff? I don't know. A circle cut out of the trapezoid. Right, and they say find the area of this, find the shaded area. So I call that a cookie cutter problem. You find the area of the whole trapezoid and you subtract out the area of the circle. Kind of with me? So that's a cookie cutter problem. You cut the cookie out of the dough. That's what's in your future. You won't see any of that unless I want to put a bonus question on there. Right, collecting material for bonus questions. I already told you bonus is going to be hard. So I can make it whatever the hell I want to, man.
Do you know the cylinder?
Cylinder? Yeah. stopping out of here. Here's your cylinder. Say this is 12 inches. Let's say this is.
We still have little kids over.
I know. Well, earlier the little kids were in their 20s, so no. Hopefully that's not something in their 20s. All right. So what's the volume? Now the volume I'd give you for a cylinder, I'd give it to you on the test. Does anybody remember what it is? What's the shape of the bottom?
1/3 times.
Circle.
No, you're thinking cone. Circle. What's the area of a circle?
Diameter.
Pi times radius.
What is pi?
Pi squared.
Right? Pi r squared. No, they're not. They're round. Right? That's the way to remember that formula. I like some of you guys are looking at me like, that's math humor. Basically, crap. All right. And then times the height. Remember I was saying if you stack pennies up, so you have the area of one penny and then you multiply by how many there are? That's the volume. But again, I'm going to give you the volumes on the test. You just got to plug and chug now. So you get pi times
18.
12 is the radius squared times the height. 18 is the height. And then whatever that is.
144 times 18, right? Or what again? 12 times.
25. Oh, dude, I lost track. What is it? 2592 pi. And then you can multiply that by pi to approximate it. Whatever that is.
That's perfect.
Whatever you get there. What's the unit's going to be? No. Volume. So what's the unit going to? What's the unit's going to be?
That's a cubic. 814.0081.
Okay. Cool. What's the volume? What's the unit's going to be?
Volume. Cube.
What's 12 units? Inches, right? So then I got inches squared times another inch is inches cubed. Right? Volume. How do you fill a room? With little cubes. How do you cover the floor? With little squares. So area is squared. Volume is going to be cubed. Yeah. Yeah, definitely, yeah. Yeah. That's the kind of problem I let you use a calculator on, obviously, yeah. And as always, if you're ready for the test, you don't have to sit there staring at me, all evil. Some of you guys, all right.
Number 5.
Stop talking. Scare me. You can, or nobody. Some of them with evil looks on their faces are not moving. So that's not why they're upset. Okay.
I can't make that 6:05.
6:05 p.m. Yeah. Yep.